Now we're going to talk about some types of reactions. We've already talked a little bit about combustion reactions. So in combustion reactions, what we have is a substance reacting with oxygen, and it forms one or more oxygen-containing compounds. Oftentimes that's water. Another thing is that combustion reactions emit heat. Okay? Combustion is burning. When something burns, it gets hot, right? So you will need to be able to predict and write balanced chemical equations for some combustion reactions. But the ones I'm going to ask you about are the ones for compounds containing carbon, hydrogen, and oxygen. When we've got those guys, carbon, hydrogen, and oxygen, the products are going to be carbon dioxide and water, because that's what they do, right? So we've got carbon, hydrogen, and oxygen only. Here with methane, there's no oxygen in the CH4, but that's okay because oxygen is the other reactant. All of the carbon goes into the carbon dioxide, all the hydrogen goes into the water, and any oxygen in here plus the extra oxygen from the air is also present in the carbon dioxide and the water. So combustion reactions make carbon dioxide and water. So write a balanced chemical equation for the complete combustion of liquid C2H5OH. That happens to be ethanol, which is the stuff in like beer and wine. Looking at this guy, we've got carbon, hydrogen, and oxygen. This is one that we can predict in Chem 1A. The products are CO2 and water because I told you they were, and you remember it. That's just it. So to write this equation, we're going to start with the compound that's given, C2H5OH, and we're told it's a liquid. What's the other reactant in a combustion reaction? Oxygen. If you don't have oxygen, nothing's going to burn. You have to have oxygen. So plus oxygen, and oxygen is a gas, a liquid, or a solid? It's a gas. And what are the products? CO2 and water. What state is CO2? It's a gas. It's carbon dioxide that's in the air, it's in all of our breath as we're breathing out. Now, water. Usually at room temperature, water's a liquid, right? Is a combustion reaction occurring at room temperature? No, it's hot. So what's the state of the water? It's a gas. Yeah. So that's a gas. Okay, so there's our skeleton, and now we're going to balance it, right? So I'm just going to use the balancing by inspection. I'm just going to start with the first element. So we've got two carbons, and over here on the right side, we have CO2 that only has one carbon. So if I put a 2 in front of CO2, now I've got two carbons on both sides. Next is hydrogen. This is a little tricky because there's 5 hydrogens here and 1 hydrogen there. There's a reason for that, because this OH group, it tells us it's an alcohol. And so it's written that way so we can tell it's an alcohol and not one of the other many compounds that have this formula. So 5 plus 1, we've got 6, right? So I need 6 hydrogens over here, so I could put a 3 in front of the water, right? Because 2 times 3 is 6. Now we do the oxygens. And this one you might want to write something down. How many oxygens right here? There's 4. And how many oxygens over here? There's 3. So that's a total of 7, right? Over here is the O2, of course. And if it wasn't for this oxygen, we'd have that odd-even problem that we had on Monday night. But there's 1 oxygen here, right? So we want to have 7 over here. 7 equals 1 plus how many? 6. I've got 1 here, and I want to change this coefficient because that'll mess up everything else, right? So I've got this 1, and then I'm going to make up the rest of them using this one. So I need 6, and they're coming in pairs. So if I put a 3 in there, it's balanced. Any questions? This is one of those things, it's like playing an instrument. You can watch somebody do it. They can explain all the details and subtleties of it. But if you don't actually try it, you'll never be able to do it, right? But it looked so easy when you did it. Yes, I've been doing this since before you were born. Here's another kind of reaction, alkali metal reactions. So the alkali metals are very reactive, and they will react with nonmetals in vigorous ways, somewhat explosive, actually. So alkali metals will react with halogens. Halogens are group 7A, according to this general reaction. And so here what we're saying is the M is standing for the alkali metal. Could be sodium, could be potassium, any of those guys in group 1. X2 is representing a halogen. Could be F2, Cl2, Br2, any of those guys. And they're going to make an ionic compound because if you have a metal and a nonmetal, it's an ionic compound. And we can predict the formula because we know what charges those guys have on the periodic table. The alkali metals are +1, the halogens are -1. And so it's going to have this formula, Mx. And so to balance it, we have a 2 in front of the metal because this is diatomic, and we have a 2 here. And so here's an example. Sodium and chlorine will react, and they will form an ionic compound. This is a photograph of sodium and chlorine reacting, it's giving off a lot of light there. So the reactivity increases as you go down. So as you go down the periodic table, the reactions become more and more vigorous, i.e. explosive. Alkali metals will also react with water. They react with lots of stuff. They react with water to form a dissolved metal ion, the hydroxide ion, and hydrogen gas. So here's our alkali metal. Could be lithium or sodium or potassium. This is going down the periodic table, lithium, sodium, potassium. And we see that this is, reacting and fizzing and stuff. And this one's actually, there's a little bit of flame that occurs here. And the potassium is just kind of throwing sparks all over the place. Because what's happening is hydrogen gas is being formed and a lot of heat, and it's hot enough that the hydrogen ignites. Kind of fun. So they're highly exothermic, can be explosive, and you may have heard stories about people putting a chunk of sodium in their swimming pool or something. Super, super bad idea. Very, very bad idea. Any questions? The halogens, those are the nonmetals on the far other side. They are the most reactive of the nonmetals. They will react with many metals to form what are called metal halides. So those elements together are called the halogens. And so when we make an ion out of them, halide. So it's like chlorine becomes chloride. And the formula here will depend on what kind of a charge that metal ion takes. Halogens can also react with hydrogen to form hydrogen halides. So hydrogen halides like HCl, HBr, in the gas state, they are molecular compounds. They're covalent compounds, but when we put them in water, they form ions. They produce hydrogen ions. They're acids. Halogens can also do stuff with each other. This is chlorine gas. Chlorine's a gas at room temperature. This is bromine down here. It's a liquid. And of course, you know, some of it's evaporating. And iodine is a solid at room temperature. But if you heat it up a little bit, it'll sublime and make this purple gas, which is kind of cool. So you could see some homework problems like this. Write a balanced chemical equation for each reaction. Personally, I really just don't like that one very much, so we're not going to do it. The reaction between aluminum metal and chlorine gas. So aluminum metal, right, is Al. And what is its state? It's a solid. If you're not sure, you can look at the periodic table up here and see what color is its element symbol. Well, it's black. That means it's a solid. And then chlorine. Chlorine is Cl. Is chlorine diatomic? Yes, horses need oats for clear brown eyes. And so this is Cl2. And what's the state of chlorine at room temperature? It's a gas. Because when we look at that periodic table, the symbol is red. So that part's not too bad. But then they're not telling you the name of the product. They're saying you should be able to write a balanced chemical equation. Like, well, in I think it was chapter 3, we did things like write the formula for the compound that forms between aluminum and chlorine. It's a metal and a non-metal, right? What charge does an aluminum ion have? 3+, because it's in group 3A. What's the charge on a chloride ion? -1, because you count backwards from the noble gases. So we can write the formula for this because we know what the charges are. AlCl3. Need 3 of these guys. Ionic compounds are almost always solids at room temperature. I can't think of an example that's not. And one thing that might help you remember that is the most widely known ionic compound, sodium chloride table salt. It's a solid, right? These guys are all solids, so that's a solid. And then how do we balance this? Well, if we start here, we've got 1 aluminum and 1 aluminum. That's great. Here I've got 2 chlorines, and here I've got 3 chlorines. One's odd, one's even. Let's double everything. Double this and double that. This is what I'm working on, so I'm not doubling that yet. 2 aluminums, 2 aluminums. Now how many chlorines? 6. Okay, so then I can put a 3 here. Let's do this one. The reaction between gaseous hydrogen and liquid bromine. What's the formula for hydrogen? H2. It's the H in horses need oats, right? They tell us it's a gas. What's the formula for bromine? Br2, that's the brown eyes part. And they're telling us that's a liquid. What's this going to make? Well, we've got hydrogen and a nonmetal. That sounds like an acid, doesn't it? So, as an acid, it would have hydrogen ion and a bromide ion. Right? That's what it forms when it dissolves in water. Right? So, what it does when it dissolves in water, those ions are going to tell me what the formula is. So there's one hydrogen for every bromine. This is HBr. Now, they didn't say anything about water here, did they? We had a gas, and the bromine was its own liquid. I wouldn't expect you to know this, but this is going to be a gas at room temperature. If it was aqueous, we'd name it as an acid. I'm not going to even talk about naming it otherwise. How do we balance this? We just need a 2 here, right? So questions like this could show up on exam 2. They could show up on the final exam. And I think a lot of times students look at them and they're like, ah. But you have all the individual pieces. You just have to put them together, right? So, just take a step back and think, well, Mrs. K said we could do this. So let's just figure it out, right? This is not a memorization thing. This is a look at the 2 elements and figure out what compound they're going to make. I'm not going to ask you to do this one because I think it's just icky.